Hello everyone, today I'm going to give you knowledge to solve this question. First, we need to start at the very beginning. In order to understand contingency tables, you need to understand the basics, like A union B and A intersection B. Also, what independent and dependent events are. Well, an independent event is when we have two events that don't affect each other's outcomes, like choosing two different highlighters from a pencil case with replacement. The first choice does not affect the outcome of the second choice. A dependent event is when the first event affects the outcome of the second event, like choosing two coins out of a wallet without replacing, because the first event will affect the second event. Okay guys, so over here we have an example of a contingency table. This contingency table shows the relationship between men and women and their choices on what they want to eat on an aeroplane. Total 65 people. And we have examples of some of the questions they may ask, including a very important one which actually shows up in the question we're going to do at the end. Now, remember what I said that the rules that we learned at the start are important? Well, they are. As you can see, the question says woman and beef, which we know because we learned our rules at the beginning. It is the probability of A, which we could say woman, and the intersection, which is and beef. Now we write it out like so, and we answer it like so. Probability of woman, intersection, or and beef is equal to 8/65. Now, the probability of choosing beef, as you can see, probability of choosing beef, we go right to the end, 33/65. What do you know? Probability of beef, 33/65. Now we come up to the main question. Is the choice of meal independent of gender? Well, but remember that to stay true to the multiplication rule, which is probability of A intersection B equals the probability of A intersection B equals the probability of A times the probability of B, right? So let's pick a few things, shall we? So let's pick probability of men and chicken, right? So probability of men and chicken is 10/65. Like so, like what we wrote here. 10/65 is equal to 0.153. Now, to stay true to the multiplication rule, it's probability of A times the probability of B. So we're going to go, the probability of men is 35/65 times the probability of chicken, which is 32/65. We times those together and we get this answer. As you can see, these two are different, which means that the rule of multiplication does not hold. Therefore, the event is dependent of gender. Okay, let's do the first half of the first. In order to determine whether people aged between 20 and 25 years lived with their parents or not, a survey was undertaken. The table below summarizes the results. Suppose that one of these people was randomly interviewed a second time. Determine the probability of that person. A male who lives with his parents. Probability of male intersection living with their parents. 40/500. Number 2. Lives with his or her parents. Probability of male intersection, female intersection lives with parents. 200/500. How do we get that, you may ask? Well, we take males and females, which is 200, his or her parents, 200 over the total 500. Probability, female lives with parents. They said, is female, given that they live with their parents. So is female, given that they live with parents, 160/270. Now, for the big one, showing all working, determine whether it can be said that living with parents is independent of gender. Okay, so we said probability that it is a male intersection parents, 40 over 500 to stay in line with the multiplication rule. Then we did this next one of probability of parents times probability of a male is 230 over 500 times 200 over 500. We got this. As you can see, the two values are different. Therefore, it is therefore dependent of gender. Now, with all things in this lesson, we always have to learn the basics. So, these are the basics of the fundamental counting principles. When we are given different choices, for example, C, D, and E, okay, the sample set will equal C times D times E. For example, how many different outfits could you put together with 4 shirts, 6 skirts, and 2 pairs of shoes? Well, like this suggests, it's going to be 4 times 6 times 2, and the exact answer will be 48 outfits. Okay, next one, arrangements with repetition. This is very important. So, sample set will equal x, and so k, as you can notice, an exponent is here. It's an x, exponent x. This means k, number of choices, x, which is the exponent, number of times you can choose it. For example, let's look at the name Aaron and how many times you can rearrange the name Aaron with repetition. But as you can see, there's nothing really repeated, so this is a very good example. So let's see Aaron. As you can see, K, 1, 2, 3, 4. 4 number of choices. How many times can we choose it? 4 times. So therefore, it'll be 4 to the power of 4, which would be 256. Now, without repetition, sample space is equal to P factorial. This is a factorial. This little that looks like an exclamation mark is not. It represents factorial notation. If you want to see how it works, it's P times P, open bracket P minus 1 times P minus 2, etc., etc., etc. Now, in numbers, it would look like 4 factorial would be 4 times 3 times 2 times 1 in descending order. Like so. Example of this would be the name again, Aaron. Okay. So let's see how many times we can put the letter Aaron in there. 1, 2, 3, 4. 4 factorial, which is 24. Now we look at permutation. It's the order over. So this looks to the order of arrangement. It's permutation, right? Now we see the n is equal to ns is equal to n factorial over n minus r factorial. This simply means r is the number of specific choices. So it's the total minus the total of the choices minus the specific choices. This will become clear in a second when I say to you that there are 7 netball players in a team who hope to be the shooter or goal attack, or goalie, you could say. How many different options are there? Now, this is a cool piece of exam technique. We write everything as so. We have 7 players, shooter or goalkeeper. That's 2, right? So, then we'll have 7 factorial over 7 minus 2, close bracket, factorial on the outside. And as you can see, we'll get 42. Now, moving on to identical items, repetition in arrangement. This speaks to the number in the sample space is equal to n factorial, the number, and the m and the p speak simply to the number of times different items are repeated. Now, Let's look at another example, but with another name, Vanessa, shall we? How many times can the letters in the name Vanessa be arranged? So, as you can see, we have 2 S's and 2 A's. This is quite important because then we can make up our M and our P. So, 7 factorial, there's 7 letters in this name, over 2 factorial times 2 factorial, M and P. 1,260. Okay, now to the final part of factorial should be calculated in this question, e.g. 4 factorial equals 24. 4 boys and 3 girls sit in a row watching a movie. Determine the number of arrangements in which they can be done. They sit in any order. Therefore, it is just 7 factorial, which is 5,040 different ways that they can sit together. Now, a boy sits at each end of the row. So, if we look at this in numbers, right? That means each end of the row is taken up by a boy. Therefore, that only leaves us with the option to rearrange the middle. Therefore, it's 5 factorial. Now, all boys sit together. Now, we know that there are only 4 boys, right? So, with these 4 boys, they can only be arranged into 4 different things. Therefore, it's 4 factorial times 4 factorial, which is 570. Hi everyone, thanks for watching. I hope you found this useful, and I'll see you in the next video.